0.67 times 3 would give us 2, and 0.75 times 4 will give us 3. Now we have whole number ratios. So this next example I will provide for you guys is where our whole number ratios do not equal an even number at the end. As with our other example, we'll start with the percentages that are given for our empirical formula. As we can see, carbon is 48.38. All of these numbers will equal 100%. Again, we don't know the mass of the empirical formula compound, so we need to convert this into grams. The easiest way to do this is to assume that we're dealing with a 100-gram sample. So our carbon, hydrogen, and oxygen will all be converted into grams using 100 grams, and then that just means that our percentages go directly into grams. Our second step is to divide by the molar mass. So carbon's molar mass is 12.01 grams, and hydrogen's is 1.01 grams, and oxygen's is 16.00 grams. Once we do this, we will be able to then determine what the minimum mole ratio is. Now that we have found out how many moles of each compound we have, we need to find out the ratio. So in order to do this, we will divide each by the smallest mole ratio, which in this case is 3.336 for oxygen. When we divide this, we can know that oxygen will give us mole. Notice that our units for mole have canceled. We will not have any units for the numbers as the subscripts. For hydrogen, we will get 2.4, and for carbon, we will get 1.2. So now we have numbers that don't match up with 0. They are not whole numbers. We cannot just assume that carbon is 1, and we cannot assume that hydrogen is 2, because we would be losing out on these numbers. So our next step is to multiply them by a number that all of them can be multiplied by in order to get a whole number. Since we know that 2 is 2/10, we can decide to multiply all of these by a number that would make it whole. In this case, the only number that they could share in common to get a whole number would be 5. So we will multiply 2 by 5, or 1.2 by 5, 2.4 by 5, and 1 by 5. Because if we multiply 1, we must multiply all of them. So when we multiply 1.2 by 5, we will get 6. And when we multiply 2.4 by 5, we will get 12. And when we multiply 1 by 5, we will get 5. Now these numbers will become the numbers of our subscripts. So our compound is going to be carbon 6, hydrogen 12, and oxygen 5. We can verify that this is the empirical formula because in the end, all the subscripts do not have a common denominator. So we cannot reduce these down to any other whole number ratio.